sklearn, linear model, passive-aggressive regressor. Description: the passive-aggressive regressor is a linear model that is trained using the passive-aggressive algorithm. This algorithm is a type of online learning algorithm that updates its model parameters based on the errors it makes on individual training examples. Inputs: X, the training data, where each row represents a data point and each column represents a feature. Y, the target values for the training data. Outputs: Self, the trained passive-aggressive regressor object. Core, the coefficients of the linear model. Intercept, the intercept of the linear model. Steps: the passive-aggressive regressor initializes its model parameters with random values. For each training example, the model makes a prediction. If the model makes an error, the model updates its parameters in a way that minimizes the error. The update rule for the parameters is based on the error and the learning rate. The learning rate controls how much the model's parameters are updated based on each error. Metrics: mean squared error MSE, the average squared difference between the predicted values and the actual values. Mean absolute error MAE, the average absolute difference between the predicted values and actual values. R squared, a measure of how well the model fits the data. Visualization plots: scatter plot of the predicted values versus the actual values. Residual plot, a plot of the difference between the predicted values and the actual values versus the predicted values. Fine-tune parameters: see the penalty parameter that controls the strength of the regularization. A higher value of C means that the model is more likely to overfit to the training data. A lower value of C means that the model is more likely to underfit to the training data. Fit intercept: whether to fit an intercept term to the model. If set to true, the model will include an intercept term in the linear model. If set to false, the model will not include an intercept term in the linear model. Maxiter: the maximum number of iterations to run the training algorithm. A higher value of maxiter means that the model will be trained for longer, which may lead to better performance. A lower value of maxiter means that the model will be trained for shorter, which may lead to worse performance. Toll: the tolerance for the stopping criterion. A lower value of toll means that the model will be trained for longer, which may lead to better performance. A higher value of toll means that the model will be trained for shorter, which may lead to worse performance. Random state: the random seed to use for the training algorithm. This parameter is useful for ensuring that the model is trained with the same random numbers each time. Uncertainty methods: confidence intervals: the range of values that the model predicts with a certain level of confidence. Prediction intervals: the range of values that the model predicts with a certain level of confidence, taking into account the uncertainty in the model's parameters. Challenges and fixes. Challenge 1: overfitting: the model may overfit to the training data, which means that it performs well on the training data but poorly on unseen data. Sample use case that resulted in challenge 1: the model is trained on a small dataset, which can lead to overfitting. Fixes to challenge 1. Regularization: use regularization techniques such as L1 or L2 regularization to prevent the model from overfitting. Cross-validation: use cross-validation to evaluate the model's performance on unseen data. Challenge 2: underfitting: the model may underfit to the training data, which means that it does not perform well on the training data or on unseen data. Sample use case that resulted in challenge 2: the model is trained on a dataset with a lot of noise, which can lead to underfitting. Fixes to challenge 2. Feature engineering: add new features to the model that are more informative. Increase the number of training examples: use a larger dataset to train the model. Increase the complexity of the model. Use a more complex model such as a neural network.